Hello, everyone, and welcome to our presentation. My name is Rebecca, and I'm representing Friends of Osprey Junction Trailhead. Friends of Osprey Junction Trailhead is a chapter of Friends of Sarasota Parks, a 501c3 nonprofit in Florida. Our mission is to support, promote, and enhance Osprey Junction Trailhead, a Sarasota County park adjacent to the Legacy Trail. You can visit the website www.ojtfriends.com. We would like to thank our sponsors for this presentation, Gulf Coast, partnering with organizations to transform our region through bold ideas, creative projects, and proactive philanthropy. You can visit their website, www.gulfcoastcf.org. And at this time, I'd like to welcome our speaker for the session, Marguerite Beckford from TreeJuvenation. Marguerite has an incredible presentation lined up for you tree lovers out there. So without further ado, let's welcome Marguerite.
Thank you, Rebecca. And it's great to be here. Thanks for having me. I'd like to, first of all, just introduce myself and talk a little bit about what we're going to go over today. So today's topic is The Secret Life of Trees, Part 1, and I'll tell you more about that as we go along. My name is Marguerite Beckford, and I am the Commercial Horticulture Extension Agent with UF IFAS Extension in Sarasota County. I always like to give just a little bit of background about myself so everyone can be familiar with just my area of expertise. I have a doctoral degree in instructional technology, design and distance education from NSU. I have a agribusiness management and marketing master's degree from UWI and a bachelor's degree in agronomy from UWI. And as the UF IFAS Extension Commercial Horticulture Agent in Sarasota County, my current extension education focus areas are urban forestry and environmental landscape management. My horticulture career has also included working in Miami, the British Virgin Islands, Jamaica, and Trinidad and Tobago. So that's just a little bit about me. What I want to talk about, we tend to preface all our presentations with an overview of what is extension. Some of you may already know what extension is, but we never like to assume because, as you might have heard, you know what happens to people who assume. And so a lot of times we get this question, oh, extension, you guys have so much information. You guys are the best kept secret, and we don't want to be a best kept secret. So we always preface our presentations with just a little bit of background about what extension is. It's actually a partnership between Sarasota County, the University of Florida, which is Florida's land grant university, and the US Department of Agriculture. And extension uses university research and resources to address local needs through community initiatives, classes, outreach, and volunteer opportunities. Extension also provides practical education to help residents, professionals, decision makers, and others in the community build a better future. And because a picture paints 1,000 words, this is a map of all the extension land grant universities and colleges in the United States. And so I always like to include this just to give you an idea that we are part of a nationwide network. If you've lived in other states, you can find your land grant extension university on this map. And so here is OSU, Washington State University, Penn State in Pennsylvania, Cornell is the land grant extension university in New York. And so we're part of a nationwide network of extension land grant universities. So extension offers a variety of programs. Today I'm going to be talking to you about horticulture, trees in trees specifically, sorry, dripping over my tongue. But we do more than just educate people about trees. We offer our Master Gardener program. Some people on the webinar today are Master Gardeners. We offer the Master Naturalist program, which educates Floridians about how to properly conserve and preserve the natural resources in Florida. We have marine-based programs, which is our Sea Grant program. We also have aquatic organism management and water quality management programs that are covered by our Florida water stewardship program and our Lake Watch program, as well as our Florida microplastics awareness project. We also do educational programs on energy upgrade sustainability, how to be more sustainable green business partnerships. We have a totally devoted program for youth education and youth empowerment. And we also do education on nutrition programs, how to eat healthy and be healthy with just an active lifestyle. So all of these are areas of extension programs that are offered through our UF IFAS extension office in Sarasota County. All right, so let's focus on trees. So this TreeJuvenation Florida extension program really is about increasing awareness of the benefits of trees to our communities. And I always like to give a plug for the National Arbor Day Foundation. You can visit their website and just do a keyword search for the Time for Trees. They have a very audacious goal of planting, I think it's over 1 million trees by 2022. And their website to find out more, but we're in partnership with all the tree organizations around the country that are trying to increase canopy and preserve canopy coverage. All right, so this is module 1 in the Tree Champ program. I'm going to tell you more about that in a bit. It's called The Secret Life of Trees. And this is part 1, naked seed tree classification. Then we also have other modules, lobes of 3, that talk about tree anatomy, plant power, that talks about tree physiology. We talk about tree planting and care. We talk about tree maintenance and pruning. And we also talk about conserving community tree assets. How do you manage your tree assets in your community? And so today we'll just go through a portion of module 1, and then we'll take your questions at the end. So the Tree Champ training program is a multi-session urban forestry training program designed to, 1, promote the awareness of urban tree benefits to communities, and 2, to empower tree champs to engage with their community on increasing canopy and protecting tree assets. And we'll talk a little bit more about why we would want to engage with our community to increase canopy and protect tree assets, just because of the myriad of benefits that we derive from trees. And so the Tree Champ program involves completion of all the modules in the Secret Life of Trees Tree Champ training program. Say that fast 3 times. And then once participants have successfully completed all modules, they'll get, a shirt saying they are a tree champ. That's the front of the shirt. The back of the shirt says "Save Our Planet, Plant a Tree." All right, so this module, our objectives are to define the terms urban forestry and urban forests, to describe various benefits of urban trees, to describe the features used to classify trees, and to describe the process used in tree identification. So what we're going to do now is we're going to launch a pre-test poll, because all extension programs like to measure how beneficial the program has been. So please go ahead and vote. If you're not sure, say you're not sure, because the whole goal is for you to have the answers to this when we poll you again in the middle of the presentation. So go ahead and vote. You'll see the poll on your screen, and you'll have to scroll down to get to question number 3.
And just to clarify, it's okay if you don't know the answers to these questions by the end of the presentation, you will. So just do your best guess. When all of the people have voted, I will display the results of the poll, and then we'll move on with the presentation.
Thanks, Rebecca. Yes, I know people are usually a little scared to take pre-tests because they say, well, I don't know the answer, but it's fine. Just go ahead. If you're not sure, say not sure, just do your best to answer the questions.
Okay, I'm about to end the poll. I'll give you just a few more seconds to answer if you haven't yet. And I do also want to mention right now that if you have questions for Marguerite throughout this presentation, you can go down to the bottom of your screen where it says Q&A. That Q&A button is available to you. You can click on that Q&A button and type any questions that you have for Marguerite. At the end of the presentation, about 45 minutes from now, we'll open up your questions to Marguerite, and I will use the Q&A questions to ask Marguerite your questions toward the end of the presentation. And without further ado, let's see the results of the polls.
Great. All right, so let's continue. If you were not sure, you will get the answers as we go along. And so this is great. Good. All right, so the term urban forest refers to the tree population which exists in built environments, which are your suburbs, your towns, your cities. And the term urban forestry is the planting, protection, care, and maintenance of trees in built environments. And many cities will actually have people on staff who are urban foresters, and their duties are to make sure that trees in parks and public spaces are being maintained well and that they don't pose a hazard to public safety. And so whichever city you live in, you can just find out who your urban forester is. And that person will be a wealth of knowledge for any kind of tree related information you need. However, what we wanted to do with this Tree Champ program is to just increase the awareness of people who are not urban foresters of the benefits that trees provide to their communities. And that's why we have this TreeJuvenation program and the Tree Champ training program within TreeJuvenation Florida. So just a bit of why we launched TreeJuvenation Florida extension program. In 2013, a tree canopy study of Sarasota County revealed 35% canopy coverage in the urban service area. And I know that the county would want that percentage to be larger than 35%. But since 2013, there has been considerable amount of tree removal as a result of land development. And because of this, I launched the TreeJuvenation Florida Urban Forestry Extension Program, just to promote awareness of the benefits of urban trees. And what this awareness will do, hopefully, is encourage more people to plant trees because, when it comes to tree removal for land development, sometimes development needs compete with environmental needs. And so even if we can't prevent trees from being removed because of land development, we can definitely encourage the planting of more trees in our community. So our TreeJuvenation Urban Forestry Community Engagement Extension Program involves a number of components. We have posters and publications displayed year-round at each library. You may have seen our posters at the library before we transition to social distancing, but our posters are at the library displayed prominently, and they provide information on benefits of trees and benefits of urban forest. We also have a Florida Arbor Day tree quest, speaking of which, this Friday is Florida Arbor Day, and we will be having a tree quest at Twin Lakes Park as well as the West Blaylock Park in Venice, the Venice Arboretum. And what Tree Quest is a scavenger hunt for trees in local parks, where it's a really hands-on educational experience for persons participating rather than just, reading publications about trees. They actually go find the trees that we've tagged, and then on each tree tag, there is a specific blurb on how much carbon that tree sequesters, how much rainfall it filters, how much oxygen it provides. So it's really a great event. This is going to be our 4th year hosting our Florida Arbor Day Tree Quest, and we've gotten really great feedback from persons who have participated that it's a great family-friendly event. We also have a National Arbor Day tree adoption event during April in recognition of National Arbor Day. So we do that at libraries and farmers markets as well as the Extension office. We also have an urban forestry summer youth workshop at libraries, and this engages youth in just hands-on activities to help them to learn more about trees and the benefits of trees. We also have a neighborhoods tree trail tour, try to say that fast 3 times, which is an interpretive neighborhood nature walk, which discusses tree identification and care. So this is just an overview of our projects that we do on an ongoing basis throughout the year, which are part of the TreeJuvenation Florida's objective to increase awareness of urban trees and to encourage people to plant more trees. So these are just some pictures because, like I say, a picture paints 1,000 words. On the left is one of our Tree Quest participants. I think that was in 2018, and his grandmother took him out on the Tree Quest, and he had a lot of fun. People will submit when they find the tree tag clues, they will submit their clue answers online, and they become eligible to win a prize. On the right is one of our master gardeners, just talking to a Sarasota County resident about the benefits of trees, and that person is actually adopting one of the trees that we had at our tree adoption event. On the top left is a picture of our urban forestry youth workshop that we do in collaboration with the libraries. And we use a project learning tree curriculum to engage youth in just interactive activities to help them become more aware of the benefits of trees. On the lower left, a picture from the Ringling Gardens, which is one of the locations where we did our neighborhoods tree trail tour. And then number 5 on the right is a picture of New College of Florida. And what TreeJuvenation did is they partnered with New College of Florida to help them become Florida's 21st USA tree campus location. And the tree campus location is a program that helps colleges to promote awareness of urban tree benefits on campus and engages students in urban forestry activities. All right. So I did talk to you a little bit about why we should even be interested in promoting awareness on the benefits of trees. I know many of you may already think trees are awesome, trees are great, and that's why you're here. But we need your help to spread the word on how great trees are and why they're great. And so the graphic that you'll see, if you can see my pointer here, the graphic on the extreme left shows the hydrological cycle of an undisturbed area of land. And so when there is precipitation, the tree canopy intercepts the precipitation. And so you will have minimal runoff and maximum infiltration. So you'll see these arrows here depicting infiltration and runoff, minimal runoff and maximum infiltration. When property is developed and there are no trees put in, no greenery put in, the hydrological cycle is disturbed. And so you'll see the arrow depicting runoff increases. So you'll have maximum runoff and minimum infiltration when there's no green infrastructure, no green space, no greenery. When green infrastructure is included in development projects, you'll see that tree canopy is now intercepting rainfall. And so you'll see that infiltration increases from the middle graphic to the graphic on the extreme right. You'll see that the arrow for infiltration increases and the arrow for runoff decreases. And so when we are promoting the benefits of trees, we tell people trees are awesome, and then they're like, yeah, you would think that. But we also want to tell them why trees are awesome. And so that increases buy-in into participating in our urban forestry activities. And so part of the promoting awareness includes us distributing publications such as these, which are similar to the tree tags that we use for TreeQuest. And each card that's displayed with our poster at the library will have a blurb on why trees are awesome. So for example, you'll see here, it says, children are better able to cope with stress when they live near trees and other greenery. And we don't make up this information. We actually take this information from peer-reviewed journals that have done studies on the benefits of urban trees. And so this blurb was taken from the Journal of Environment and Behavior. So on the front of our postcard, we talk about how awesome trees are. And then on the back of the postcard, we talk about why trees are so awesome. And so you'll see here, for example, the flowering dogwood, over its lifetime, it will have sequestered over 3,000 pounds of carbon. And that's why I say to everyone who will listen, if you're breathing, you should plant a tree. Because as we expel carbon dioxide and carbon monoxide, you see here, through our vehicle emissions, etc., trees are the unsung heroes of our environment that are absorbing the carbon dioxide and sequestering it, and also absorbing other air pollutants. In addition, trees will intercept over 1,000 gallons of rainfall during your annual rainfall event. And so these are just some examples of the kinds of information that we put out to increase awareness of trees. And so I'm not going to go into detail in the other postcards, but I'm just here to give you some examples that we do have different variation of each postcard, talking about the mental health benefits of trees and how people actually feel better. Their well-being is improved when they're surrounded by trees and green space. Trees are very important in reducing what we call the urban heat island effect, where pavement and hardscapes that will hold on to heat during, say, any kind of daytime temperature increase, trees will help to mitigate those daytime temperature increases. So trees will actually reduce a city block by 10 degrees Fahrenheit in summer. And I mentioned trees benefiting us by promoting cleaner air, contributing to cleaner air, I should say, and trees benefiting our communities by contributing to cleaner water, because when the canopies intercept the rainfall, it filters the stormwater runoff, depending on the tree, between 3 to 88%. Now, when we mention that particular statistic about filtering rainwater from 3 to 88%, we have gotten questions. Why is there such a wide variation between 3 to 88% of the rainwater being filtered? And I put this graphic in just to explain that it depends on the canopy structure of the tree. So if your tree on the left is an X-current tree where it has a central leader, if you think about like your bald cypress or your Norfolk Island pine, you will have different interception rates with an X current tree versus a D current tree that has multiple scaffold branches, for example, your oaks. All right, so let's dig in to the meat of the presentation. Having gone over the benefits of trees, let's look at tree classification and tree identification. So the subtitle of this module is Naked Seeds. And really, we're trying to differentiate between the two major groups of trees, which are your angiosperms and your gymnosperms. Your angiosperms produce flowers and seeds that are enclosed by fruit. And so your examples will include your mango trees, your papaya trees, your peaches, plums, apple trees, etc. All of those are angiosperms. The second major group of trees are your gymnosperms. These are also called conifers. They do not bear seeds enclosed in fruit. Their seeds are considered naked or unprotected because if, for example, you see on a female pine cone, once the pine cone opens, the seeds are scattered, and so because of that, gymnosperm seeds are considered naked because they're not enclosed in a fruit. So this is just a summary of the difference between your angiosperms and your gymnosperms. Angiosperms bear flowers and their seeds are in ovaries. Gymnosperms bear their seeds in cones and their seeds are naked. They're not enclosed in an ovary, and I'll go through some additional information that will clarify that point. Many angiosperms are insect pollinated because they have attractive flowers, fragrant flowers. Most gymnosperms are wind pollinated. Angiosperms can be evergreen or deciduous. Gymnosperms tend to be mostly evergreen. Angiosperms will inhabit all life cycles and habitats, whereas most perennial shrubs or trees, most gymnosperms are perennial shrubs or trees, and they often frequent dry habitats. And so this particular point, you will find an angiosperm growing in aquatic environments, completely submerged in water. It's very unlikely you will find a gymnosperm growing in a completely submerged habitat. Your angiosperms are non-resinous. And so whenever the bark is injured, you'll see sap flowing from angiosperms, whereas gymnosperms are resinous. And that's why pines have been famous for, turpentine tapping, because the sap is resinous and not as fluid as your angiosperm sap. And then your angiosperm vessels that the plant relies on to transport nutrients and water are xylem vessels. We won't go into detail in this module, but in later modules, we go into detail about what xylem vessels are and what they look like. And in gymnosperms, those transportation vessels are xylem tracheates. All right, so this is just an overview of the angiosperm life cycle. It starts with a seed that was enclosed in an ovary, and an ovary is, a fruit is actually the enlarged ovary of the flower. So you'll start with a seed, it germinates into a seedling or a young plant. And once the plant matures, it will switch from its vegetative growth phase to its reproductive growth phase. So it will start to produce flowers, which is the beginning of its reproductive growth phase. The flowers will get pollinated, either self-pollinated or animal pollinated, wind pollinated, etc. Once they're pollinated and the ovules within the ovary become fertilized, then those fertilized ovules are enclosed in the maturing fruit. So a deeper dive into how angiosperm seeds develop. When you look in at the cross section of your flower, there are some flowers that are called perfect flowers in that they have the male reproductive parts, which are their anther and filament, collectively known as your stamen, as well as your female reproductive part, which is collectively called as the pistil, made up of your ovary, your stigma, and your style. So your perfect flower will actually have male reproductive parts and female reproductive parts within the same flower. You also have imperfect flowers that will have only male parts or only female parts. And we go into details about flowers because part of the tree identification process looks at the structure of flowers and you know, the shape of flowers. Are they pistillate flowers, as in, they have only female parts, or are they staminate flowers, meaning they only have male parts? So after flower development, the pollen is released by the anther. So your pollen grains will mature, your anther will release pollen grains. Pollination will occur when pollen grains land on the stigma. So the pollen grains will land on the stigma. Compatible pollen grains are induced to germinate by enzymes, which are released by the stigma. And then the pollen grain will grow a pollen tube. It germinates and it grows a pollen tube, and that pollen tube will deliver the male gametes to the ovules within the ovary. Once the ovules are fertilized by the pollen grain, then you'll have zygote and embryo development. Just one point to mention here. It is interesting to note that even though a flower cannot control what pollen grains land on the stigma, only compatible pollen grains will actually germinate, and these compatible pollen grains will actually react to an enzyme that's being put out by the stigma, and that is what will trigger compatible pollen grains to germinate. So once the ovules are fertilized, the embryo develops within the ovary, and so you'll see that at the base of the apple flower is where the ovary and the ovules are. Pollen will land on the stigma. The ovules within the ovary get fertilized, and then your embryo develops within that ovary. And so this ovary gets swollen, as you can see here, and that swollen ovary becomes your apple, enclosing the seed. And I always like to say that to quite a degree, plants are con artists because they're not producing fruit because they're, kind, nice plants that want to give you a fruit. The fruit really is an incentive for animals to eat this fruit and disperse the seed to help this plant reproduce and propagate the next generation. And so seeds are dispersed via various methods, including wind, water, and animals. So just some examples of trees, and I want to pause right here just to say that whenever we give extension classes, we always assume that, I'm using that word again, but I'm using kind of tongue in cheek. We always teach to the center of an audience. We assume that there's some persons in the audience that may know way more than what we're teaching. And we also know that there are persons who know way less on the topic that we're teaching. And so we try to do a mixture of both and try to teach to the middle. So persons who they're totally familiar with this part of plant anatomy and plant physiology, we just like to say bear with us, because we tend to teach to the middle of the audience. All right, so on the left of your screen is a southern magnolia. It's a popular street tree, prized for its blossoms, and these are just examples of popular angiosperms. On the right of your screen is a Douglas oak. You won't see many of these in Florida. These are native to California. But the thing about oaks in general is that they can live for many, many years, upwards of 100 years, sometimes 200 or 300 years, and they get really large. A mature Douglas oak can get up to 80 feet wide. Other popular angiosperm trees include our red maples, and on the left you'll see your red maple turning red. The leaves turn red at this time of year, and that's actually in response to the release of leaf pigments called anthocyanins. When chlorophyll production is reduced or it ceases, and chlorophyll is your green pigment, and so your anthocyanin leaf pigments become more pronounced. On the right is an example of a holly, which is another popular angiosperm tree. And your hollies exist as either a male holly tree or a female holly tree. And so it's only the female holly tree that will bear berries. Any holly tree you see bearing berries is a female holly tree. And so that wraps up just the overview of our angiosperms. And the examples I gave will tie in why it is that we go into depth about the flowers and the seeds, because when you're identifying trees and classifying trees, you tend to begin at either the leaf shape, etc. We'll talk about that in a bit, or the flowers are usually one of the identifying characteristics we use in identifying trees. Okay, so now let's talk about the other major group of trees, which are your gymnosperms. And this is just an overview of the gymnosperm life cycle. And you'll be looking out for differences between this and your angiosperm life cycle. So in your gymnosperms, you'll have your male cones and your female cones. Your male cones are responsible for producing pollen grains. And so here you'll see that between the scales of a male cone are going to be pollen grains. These pollen grains will mature and then get released. The female cones, at the base of each scale and the female cone will be an ovule. And once pollen grains are released, many people, to their chagrin, during spring, when all the trees are just releasing pollen grains, the pine trees and the oak trees, etc., and your allergies are going crazy, it just means that love is in the air. So what happens is the female pine cone has ovules at the base of the scales, and the pollen grain, the female pine cone will open ever so slightly to accommodate the absorption of the male pollen grains. Many gymnosperms will bear both male and female cones on the same plants, but there are a few exceptions. So just to recap, your male cones will produce pollen grains. Your female cones produce ovules at the base of the female cone. And then the scales of the immature cones, if you see a cone that's this open, it means that it has already matured and it has released mature seeds. Immature female cones will still be green, but they will open the scales ever so slightly to accommodate the absorption of male pollen grains. So these are just some examples of your popular gymnosperm trees. On the left is your slash pine. What's interesting about trees in general, but slash pines in particular, when pines grow in high density spacing, they will develop thinner trunks than those that are grown as solitary trees because they're lower light levels. And so what they do is they will actually sacrifice growing wider for growing taller so that they can access more light. On the right is your bald cypress, and your bald cypress will develop aerial roots at the base of the trunk. And these aerial roots are called knees. And you'll see the knee development be more pronounced in shallow water. And these aerial roots actually help the cypress, the bald cypress, to quote unquote breathe, to access oxygen when its roots are submerged. On the left, you'll see your eastern red cedar. It's a gymnosperm, but it's not a true cedar. True cedar trees are actually angiosperms, and they belong to the cedrus genus. But your eastern red cedar does not bear fruit. Those tiny berries that you'll see on your eastern red cedar are actually cones and not fruit that you would actually see on an angiosperm tree. On the right are just some examples of popular trees that are grown as Christmas trees. Those are gymnosperms, and those include your spruce, your pine, your Leland cypress, and your spruce pine, sorry, and your Virginia pine trees. All right, so now poll question number 1. Hopefully you do know the answer to this. I'll see 100% of people say, yes, I know the answer, and they'll have the correct answer. So we'll just give you a minute to answer this poll. Okay, and Rebecca, if you've seen that most people have voted, you can end the poll once most people have voted. Oh my goodness, that's awesome. I'm so happy. So 96% said gymnosperms are wind pollinated. That is true. Um, most gymnosperms are wind pollinated. Okay, so we'll close that poll and we'll carry on. And again, please feel free to type your questions in the Q&A. We will get to those at the end. We just want to get through our presentation. So if people have to go at the end, they're free to do so. All right. So when we're talking about the secret life of trees, we have to also include trees that are not really trees. And I say this because botanically speaking, there is a specific definition for what is considered a tree. Under that botanic definition, palms would not be considered trees because palms do not have more than one growing point. Neither do cycads. They have one growing point. If you see the picture on the right, a cycad will have one growing point that's at the center of the crown. A palm has one growing point, the picture on the left, which is at the center of the crown. Strictly speaking, a tree, botanically defined, will have several growing points, definitely more than one. And so that's just one of the reasons palms and cycads are not considered trees, even though they may look like trees. However, colloquially, we will say palm tree, just because, the canopy is elevated above ground, similar to that of true trees. And so we will say king sago palm, which is not a palm. We will say palm tree, but we just want to make the distinction when we're talking about trees. So palms, because of their elevated canopy, they're considered tree-like, but they're not botanically categorized as a hardwood tree because they do not have hardwood deposits the way other trees would deposit hardwoods. And then some cycads you will see have elevated canopies and woody stems, like your king sago. Other cycads don't, like your coonties and your cardboard palms do not have elevated canopies or woody stems. Other examples of tree-like plants will include your ponytail plant on the left. People will say, you know, a ponytail palm, it's not a palm, and it's not a tree. And as well as your pandanus, called screw pine, but it does not belong to the genus Pinus. And botanically speaking, it would be considered a shrub-like plant with an elevated canopy, but not necessarily a tree. One interesting thing to note about your pandanus or your screw pine is that they're dioecious, meaning that they bear separate male and female plants, like your holly. Your other examples of tree-like plants include your plantains and your bananas. They're not true trees. They don't have a woody trunk. It's all herbaceous. Your traveler's palm as well could be considered a tree because it has an elevated canopy, but it is not a true tree. Neither is it a palm. It is in the bird of paradise family. All right, so let's look at tree identification. And we're not going to spend a lot of time in this section because this really is your introductory module. I'm going to mention some things here that we do way deeper dives on these topics in other modules of our Tree Champ training program. But this is just an introduction to tree identification and what you can use to identify trees as you engage with trees in your community. So tree identification is done based on several factors, including leaf shape, leaf margin, leaf arrangement, the kinds of flowers or cones that the tree bears, the bark color, and the bark texture. Leaf shapes are quite varied, but they're one of the key characteristics used in identifying trees. Leaf shapes, as you can see from the chart on your left, they're described using standard terminology, and leaf shape charts are a helpful tool for differentiating various leaf shapes. And so, for example, you look at a leaf and you're like, oh my God, I wish I knew what kind of tree this is. You could actually take a leaf, compare it to the leaf shape chart, and you'd be able to figure out, okay, well, it's a scale-like leaf, or it's an obovate leaf, and that will get you on the right track to figuring out how to identify the tree. So just some examples of subulate and acicular shaped leaves. Examples are your lucina, acicular is your pine, and then your linear leaf shape is your bottlebrush tree. Leaf shape examples again, you'll have your laurate shaped leaf. Examples are your tamarind, and that's a leaflet. I'll explain more about leaflets in a bit. Your Vera wood is considered to have an oblong leaflet, and your oval leaves, I should say, can be found on your green buttonwoods, for example. Now, in addition to leaf shape, we can also use the leaf margin to help identify trees. And so your leaf margins are going to be described using standard terminology as you see here. And so examples of your leaves with entire margin, it means that the margin is completely smooth. Examples would be your podocarpus. Cerulate means that it's a little bit of serration, but the serration is fine and not coarse like your serrate leaf. So you'll see that there's coarse serration in a serrate leaf versus fine serration in a cerulate leaf. Examples of your cerulate margins would be your cordia and your yellow cordia, and examples of your serrate margins would be your neem. If you can see my pointer here, you see that the margins of the leaf are serrated. All right. So more examples, your doubly serrate margins on your golden rain tree, your dentate margins on your loquat trees, and your crenate leaf margins on your key lime trees. And so this just gives you an idea of when you're trying to identify what kind of tree you're looking at, how helpful the leaf shape and the leaf margins are. Another key characteristic we can use to identify trees include the leaf arrangement. And leaf arrangement is a term used to describe the pattern in which the leaves are attached to the main stem. So we'll have our alternate arrangement, which means the leaf is attached to the stem at only one leaf is attached at a node. A node is just a growing point where a leaf is attached to the stem. So here would be a node and there's only one leaf at this node. And then on the alternate side of the stem, one leaf is attached at this node. And then on the alternate side of the stem, another single leaf is attached at the node. The next kind of leaf arrangement is your opposite leaf arrangement, where the node where the leaf attaches to the stem, the node has two leaves opposite each other, and that's your opposite leaf arrangement. Then we'll have our world leaf arrangement, and this is where your leaves are attached to the node more than two in number. And so you might have 3 leaves attached to the node or 5 leaves attached to the node. And that's your world leaf arrangement. We discuss this because when you're trying to identify a tree, you will look at leaf arrangement in addition to the other characteristics we just described. And so these are examples of types of leaf arrangement. You'll have a simple leaf where there is one leaf and there's an auxiliary bud at the base of the leaf. Then you'll have leaflets where the entire margin is composed, the entire leaf, I should say, is composed of many leaflets. And so this is called a compound leaf because the entire stem here has leaflets emerging from either side. And so this is called a leaflet. Each of these is called a leaflet and the entire thing is called a compound leaf. And so you can have compound leaves that are bipinnately compound. We won't go too deeply into that in this module, but you'll have bipinnately compound or palmately compound. Let me just explain that a leaf that has leaflets emerging from one central point is considered a palmate leaf. And so it looks like the palm of your hand. The leaflets are coming off from one central point. Whereas a compound leaf that has leaflets along a central margin is considered a pinnate leaf. And pinnate is actually from the Latin word pinna, which means feather. And so you'll see that a pinnately compound leaf will have leaflets emerging from either side of the main stem. So just to clarify here, we're talking about pinnately compound leaves, and your leaflets can either be oddly pinnate in that they only have an odd number ending at the end of the leaf. So the leaf, there are an odd number of leaflets. Or you can have even pinnate leaves, which will have an even number of leaflets at the base of the leaf. And so here's the difference between your even pinnate leaf. So remember, the entire thing is a leaf comprised of leaflets emerging from a central stem. And the leaflet, which is pinnate, can have an even number of leaflets at the end or an odd number. And so the leaf would be considered oddly pinnate, having odd numbers of leaflets, or it can be considered evenly pinnate, where it has an even number of leaflets. So your leaf attachment is also another way you can characterize tree identification, and we won't go into depth here. As I said, we go more into depth into other modules, but petiolate leaves means that there's a stalk attaching the leaf to the stem. And your sessile leaves means that there's no stalk attaching the leaf to the stem. It's just directly attached to the stem. And then our sheathed leaves will be attached to the stem with a sheath wrapped around the stalk, okay? We'll have clasping leaves, perfoliate leaves, connate perfoliate leaves, and peltate leaves that we won't go into here. All right, so poll question number 2. Pinnate leaflets are described as odd or even based on the number of leaflets. And once we're done with this voting, we'll wrap our session up and take your questions. And so Rebecca will end polling once most people have voted. Great, this is awesome. I'm so happy. I hope you can tell from my voice. 100% of you got it right, that pinnate leaflets are described as odd or even based on the number of leaflets at the tip. Great, okay. So we just have a few more slides to go into, and then we'll be done with our presentation, take your questions. All right. So you can identify your trees by your flowers. That is why we look closely at the flower diagram. You want to know, do your flowers have both male and female parts? If it does, if the flower does, then it could be one kind of tree versus another kind of tree. Trees can also be identified by the fruit, the cones, whether it's the male cone here or the female cone. And then your flowers, you can also break down the description of flowers based on how the flowers are shaped and how they are arranged on a tree. We're not going to go into individual detail here, but suffice it to say that flowers are classified based on how they are arranged on a flower stalk, whether it's a single flower or it's a panicle, which has multiple flowers arranged on a central stalk. Flower shape is generally consistent across plant families. And so your Asteraceae family, which is your daisy family, all the plants in that family will have flowers that are shaped similarly. This is just a floral diagram that we won't dive into here. Just want to give you an overview of how botanists actually use flowers to classify plants. And so this is an example of your oak flower and the flower diagram that accompanies the oak flower when they're trying to classify different types of oak. Is it a live oak? Is it a laurel oak? And on the right is a floral diagram of your magnolia flower and flower pod. When we're identifying conifers, we look at the color, shape, and size of the cones. And so you can actually identify pines based on the size of their cones. The large cone on the left being your longleaf pine and your really small cone coming from your pinyon pine, okay? We went through the anatomy of your pine cone, that your female cone bears the seeds at the base of the scales, whereas your male cone will have pollens on the inside of the scales. So the last characteristic that we use to identify trees are going to be the texture, color of the bark. And so tree bark is usually one of the first tree characteristics examined when we're identifying trees, because we tend to be closest to the bark. Typically, we can't easily access the leaf of a tree that's, say 12 feet or 15 feet tall, but we have up close and personal access to the bark. And so tree bark is usually one of the first characteristics we use to identify trees. And tree bark is identified based on the color and the texture of the bark. When you're identifying trees by the bark, you want to know, is it one solid color or is it multiple colors? Is it smooth or is it rough? Your rainbow eucalyptus on your left, no brainer. When you see it, everyone knows it by its colors. Your white birch on your right also tends to be a no-brainer when identifying it, even when there are no leaves on it, just because of the distinctive color of its bark. Our gumbo limbo on our left is red barked, and they also call it the tourist tree because the bark peels off like, you would when you have a severe case of sunburn. Your sycamore also has a distinctively colored bark, and that's your tree on the right. Texture, when we're looking at the texture of a bark, we want to know, is it smooth? Does it have lenticels? Does it have scales? Does it have plates? Does it have ridges? Does it have flakes? And so these are examples. Tree bark with lenticels, which are just pores in the bark. Is it peeling? Does it have vertical cracks, etc.? Okay. Does it have plates? Does it have ridges, uninterrupted ridges, or broken ridges? And we get more into detail in subsequent modules. So we just wanted to give you an idea of how to identify trees by bark. And while you're voting, this is the last question. While you're voting, I'm going to take a look at your Q&As so I can prepare. Okay. And then Rebecca will end polling once most of you have voted. Okay, great. And again, the answer to that is true. Tree bark is one of the first characteristics examined when trying to identify a tree because we're up close and personal to the tree. Okay, so in the Q&A, someone asked about tree ID resources. This is, the end of our presentation, pretty much, where I just give you some additional resources. So these are two good resources. You can actually get them at the UF IFAS extension. If you see my arrow here, if you search for UF IFAS extension bookstore, these guides are available, and they have a dichotomous key in the back that it will help you to identify your trees. And then in the Q&A, there was a question about development requirements for tree removal. Sarasota County and many municipalities require persons removing trees to apply for tree permits. And so there is a permitting process required for tree removal. These are just some additional resources for tree ID. You can actually take a picture of a leaf. Once you have this picture, this app, and it will help you to identify the tree. The Arbor Day Foundation also, their website also has tree identification tools. We also have a publication on how to identify a tree at the UF IFAS extension website. So just do a search for UF IFAS extension. You can find this publication there, download it. It's very useful. And so with that, I'm going to wrap it up. This was the first part in our 6-part Tree Champ training session. If you want to participate in other modules, feel free to contact us. And thank you so much for your time. I know we met a few minutes over, but thank you so much for your time. And here is my contact information. And with this, I'll turn it over to Rebecca.
Wow, thank you so much, Marguerite. We are giving you a virtual round of applause. Your knowledge is impeccable. I learned so much, and I know so many people learned so much today. Thank you so much for your presentation and for your expertise.
Thank you for having me. And someone asked in the chat box, can a mango seed grow a mango tree? Yes, it can. But you would be better off purchasing a mango tree, because when you plant a tree, especially like avocados and mangoes, they take an extremely long time for you to get fruit from the tree, upwards of 5 to 8 years for that tree to bear from seed. So it's better if you bought a mango tree.
That does seem much more efficient. Thank you so much, Marguerite. We really appreciate you and your expertise, and thank you for providing such an informative session.
Thank you for having me. And, if anyone wants to ask other questions, I know some people have to run, but my contact information is there. They can email, call, etc.
Great. I will show it really quickly. This is the information she was talking about, mbeckford@sc.gov.net or telephone 941-861-9825.
Oh, one more thing, Rebecca. I'm sorry. I know you probably want to wrap up, but someone asked, will the presentation be available? We don't host the presentation on our website, but anyone who wants a copy, we can give them a PDF copy if they just email us using the contact information on their screen.
And we actually will be sharing the recorded presentation, and we can share the recorded presentation with you as well, Marguerite. But if you go to the website, you can access the recording that all of us experienced live just now. So I'll give you more information about that in just a second. All of us at Friends of Osprey Junction Trailhead Park, thank you for attending today. We're delighted by the enthusiastic response, and we look forward to bringing more quality content to you next month. Through a special partnership with Sarasota County Centennial 2021, our featured presenter on Thursday, February 11th, again, that's Thursday, February 11th, will be Dr. Frank Castle, a noted historian. Dr. Castle will be discussing the formation and history of Sarasota County. He's the author of many history books, including Creating Sarasota County. This session is part of a year-long celebration of the county's 100th year anniversary. You can register online at ojtfriends.webinars.com. Again, that's ojtfriends.webinars.com. If you'd like to access the recording of this presentation, you can visit us at our YouTube channel. Just search for Osprey Trailhead Junction and you'll visit our YouTube channel. You can see our recording there. Thank you again to Marguerite, and thank you to all of you for joining us. We look forward to bringing you more quality content next month. Until then, thanks so much, and we'll see you next time.